Okay, today I am going to talk about the measurement units, or you can say simple calculation or maths. Because whenever you are designing system, there are some basics sequence. You can say surely whatever the system you are going to design, first we have to understand the customer requirement, maybe functional requirement, non-functional requirement, and then understand the complete system. And before going to designing your system, high-level designs, system architectures, going to design. So before that, we have to understand the some capacity uh, which for which the system are going to design, like maybe simple mathematical, the what number of storage you require, what are the throughput we are going to, what kind of latency we are going to the meet. So according to a latency, throughput, and storage capacity, size, bandwidth, you can say many things. So accordingly, you have to design your system. So before going to high level designs, make high level component diagrams, architecture diagrams, it is a very important as a engineering teams. We must calculate the what the storage we required depend upon the system you are going to design for 1 year, 2 year, 10 years. So what, how much storage capacity we require depend upon the number of user, number of requests, number of load, number of timing, and similarly, what kind of throughputs we are expecting, what kind of latency we are expecting right now. So these are the some key terminology. So this is not a very, can say, important. Might be you already aware those, but just for the refreshment perspective, because this is a very simple maths, and we already know the maths. Okay, so just rephrase. You can say just rewind. Hey, this is also one of the very key factors in your system designs. You have to must calculate the capacity, storage calculation, what the storage size you require. Accordingly, you can scale your system. Accordingly, you can select your technology. You can select your designs approach, right? So first, always you can, whenever you start any system designing, you have to understand the customer requirement, functional requirement. You can understand the non-functional requirement that clarifies. Then we have to, before going to start your high-level designs of the system, let's calculate some storage capacity, what kind of system customer want. Accordingly, you have to go and design. So this is also, you can say, third basic steps in the system design: functional requirement, non-functional requirements, and after that you can to calculate the storage. And once done, then you can get some basic idea about like what the system look like. So I'm going to just rephrase some very simple meaning what the units are for storage or throughput or latency. We already talked about the latency. Storage means database. Nowadays, for storage, just be aware because the storage generally all the cloud providers are providing to us, but we have to tell how much capacity, how much size of the storage file system database we want. Accordingly, we have to configure our cloud. So let's talk basics. So first, I'm going to talk the storage units. So generally, these are the very simple, but still you have to just focus. So generally, whenever in the computer system, we are going to store any informations, any data, maybe text data, maybe blob data, maybe images, maybe photograph, maybe video, anything. So in the computer perspective, each and everything generally is stored in the form of bits. Bit is the basic units of the information, data, message, video, photo. Whatever the information you are going to store in the system, the basic information, basic unit is the bit. So generally in the computer system, bit is represented as a two possible value, maybe one zero and maybe one two one. So these are two possible value of the bit. So storage unit, basic unit is the bit, and bit can be zero or can be one. So you can say finally bit have only the two value, maybe zero or one. Due to that, sometime you can say it is the binary system. So generally in the computer, whenever we study the basic computer science, when we talk about the memory storage, always we are start learning bit binary systems. Okay, so but with the help of this bit, nowadays we are make more units of the measurement. Like whenever you are going to make a group of 8 bits, that's become a byte. So these are, you can say, two more basics units, bit and byte. Bit is represent just only basic unit of information, and that's after that you can go to combine this 8 bit. So 8 bit group of 8 bit we can say byte. So generally nowadays whatever the data, maybe one single character or single number or any image, any single character or any printable character, you can say, whenever you store in your system, you require at least a byte. That means 8 bit data required to store only single. Let's say I want to store only A or B or 1 or 2 or 3, because all are these are the mathematical number. And the very very good things, our text, our image, our video, our audio, whatever the finally in the computer system, each and everything considered as a data in the form of 0 or 1 binary number. Every all the characters, all the number systems, we have a already computer science have a analogy so that we can convert every characters or symbol into the math number. Like let's say example, like you are typing A. So generally as a human being we are knowing it is A, but from the computer perspective, from a storage perspective, it is just mathematical number 65. A 65 can easily be converted into the binary number 01 format. If we have any mathematical number, okay, we can easily convert into the binary system 01. And accordingly, you can decide they required 1 bit, 2 bit, 8 bit, or might be you are going to store some more data, then it required more bytes and more bytes. Due to that, we have a lots of other units we can also measure. So these are the basic information is a byte. So generally, sometime maybe interview was, can you calculate the capacity in a bit or the byte? So preferable way we talk the more defines unit, like maybe you can talk kilobyte, or maybe you can talk megabyte or gigabyte or terabyte or petabyte or exabyte or zettabyte or yogabyte. These are the lots, but you can say first we have a 1 bit, and whenever a group 8, then become a byte. Whenever you are going to 2k power 10 bytes, this is the byte, then become a kilobyte. Similarly, if 2k power 20 bytes, it become a MB. If 2k power 20, 30 bytes, it become a GB. 2k power 40 byte, it become a TB. Similarly, 2k power 50, TB. 2k power 60, EB. 2k power 70, GB. 2k power 80, YB. So these are the everything you can measure in the power of 2. Why? Because this is the binary system. A binary system we can assume power of 2. The power of 2, you can say the power of 2 power 0, that means 1, 2, or 3, 4, similarly. So here, this is a basic mathematical, but we have to understand whenever you can say, we can talk maybe KB or MB, GB, TB, PB. Okay, these many you can say we have to understand the basics of bytes if you talk. So here different terminology. You can understand one KB can be took about 10 bytes, or you can say 1024 bytes. If you calculate, it will come to 1024 bytes. Or you can say MB. The MB can talk on two way in the form of byte took about 20 byte, or you can say the 1024 KB. Or similarly, GB, you can say GB 1024, you can say just MB 204 MB megabyte, or you can say 2 power 30 bytes. Or similarly, TB means 1024 GB, just previous 1024. Whatever the previous, you can say make a 1024 byte. So here say this is the byte, this is the byte, byte come 1024 byte become a 1 KB. Similarly, this KB become a this. So this is the basic understanding. You can talk these unit KB, MB, GB, maybe respective KB or MB or GB, or you want to talk flat bytes. The generally calculation in the byte happen. So these are the basic units. So let's understand some basic conversion, because whenever we talk to the customer or when designing system, someone say, hey, let's calculate in the form of KB or MB or GB. So this is a basic understanding. This is not too much complex conversion between any unit to any types. As simple. If you have a 1 KB, you can simply say the 1024 byte. Or you have a 1 MB, so 1024, just previous one KB. That means a KB. Similarly, what is the GB? GB means 1024 what? Previous one MB. So here you can say MB. So let's say want to 1 PB. What the 1 PB size would be? 1024, and previous one TB, that will become a TB. So just 1024 and the just upper top one, you can say, if you just remember KB, MB, GB, TB, PB, EB sequence, and that you can easily conversion happens. So these are the basic 1 KB equal to 102 byte बोल सकते हो, and similarly 1 MB 102 KB 1 GB 1024 MB. So these are the sequence. If we please memorize this sequence first, KB, then MB, then GB, then TB, then PB, then EB, then GB, then YB. So let's do some simple understanding about the conversion. So these are the common conversion. So whenever you want to convert from one unit of storage to another unit, generally it's a simple two mathematical operation we have from. We can go with a division operation, or we can go with a multiplication operation. These two operations help us to make conversion of anyone. Let's say you want to convert our kilobyte, then we have to just divide 1024 to the number of byte, whatever number of byte you have. Maybe you want to convert your kilobyte to the megabyte, so whatever the kilobyte you have, just divide 1024. Or whatever the you have MB, you want to convert to the GB, just divide 1024 byte. Or similarly GB to TB. So if you have understand the previous one, whatever the sequence, if you not miss, let's you want to calculate your uh, terabyte to the petabyte. So whatever the terabyte you have to divide 102 for your, then you can get the petabyte. But you must need terabyte, because the previous one the terabyte. First, how to calculate terabyte? Terabyte again divide the GB. Whatever you have a GB, then you divide by the MB. So you have to ensure that if let's say you have only KB, then you have to first convert KB to GB, GB to TB, and then TB to PB. These are the sequence you have to be carefully aware. You cannot flatly go and divide to 1024. Whatever the you are going to calculate, just calculate the before one. Before one. The sequentially you can calculate. Whatever the byte we have, first calculate KB, then MB, then you can calculate GB, then you calculate TB, then PB. So these are the sequence we have to maintain because you have to just memorize them. Then you can easily just flat 1024, just divide them, divide them, divide them. Okay. So these are two operations, division and multiplication, help us to convert any unit to any unit. Finally, these are the why convergible? Because these are the different viewpoint. Let's we have a these are some bit of data. Finally, each and every information is stored in the bit. Okay, in stored in the bit. Every bit contain maybe zero value or one value possible value. So this complete data we can view, we can talk. Hey, we can say hey number of bit, or we can say number of byte, or we can say KB, or we can say MB, we can say GB, we can say TB, we can say B. So these all the units are just representational, the different way to talk your actual information. So these are the units you can talk any. You can talk flatly, only the bit, it's okay. But whenever talk bit, bit is so longer number. So might be the memorizations is very hard. So you can say, hey, just divide those into 8 and get the byte. Maybe byte is so longer number, memorizing byte is also very problem. So let's convert byte to the KB. Again, divide on 0 to 4. Until you have a sum 10, 100, 200, 500. These are the memorizable number. But the bit is very long number. So these the number of different measurement units are made. So that whenever we are going to talk, we are going to the very simple math number and with the different units. So don't say if you talk the let's talk about the gigabyte. So gigabyte is also just one way to speak about your bit. So what actual information always is stored in the bit, not stored in the GB, PB, byte. Every information is stored in the bit. To instead of calling bit, 10 bit, 100 bit, 1000 bit, million bit, so instead of that, we have a different unit. You can, if you divide the bit by 8, you can get kilobyte. Again, divide 104, 1024, they get over. Again divide 1024, you can get MB. Again divide, you can get GB. Again divide, you can get it. So these are the different techniques which help us to talk, speak your number of bits. So finally, be aware whatever the information is stored in the computer, always is stored in the binary format. 1 and 0. 1 0 is also not a number. You cannot say 0 means be carefully. Just for your references. Here's a binary number. This day I store the 0 and 1. If you talk, we understand 0 and R1. These are also mathematical number. 0. These are also required to store 8 bit. 1 is also one number. One number. 1 is also required to store 8 bit. So here the 60, I think 58, some the number of the ASCII value of the one. Okay, so here 0 and 1 actually in the computer system now has to show the 0 and 1. Actually, these are the some voltage, some electricity pulses, high volt and low volt something. Okay, so these are just talking representational. Hey, 0 and 1. Actually, in the computer, because computer is an electronics device, they only understand the language of your voltage, energy. So here 0 and 1 is the actual representation of your electronics, electric forms. No, might we have remember the science. This is the 0 byte 1, 2 in this way, in this way, in this way. So this is the way whenever you is under component. This is the if voltage is low, then it is 0. Voltage is high, that's just understood it is a 1. It is a 0. It is the 1. It is a 0. So here 0 is 1. Also not the your number system. Just I'm telling you, see, it is the representational of your voltage, uh, fluctuation, some maybe low volt or high volt, you can say high voltage of energy. And finally, data is for our understanding, for learning, we are talking a 0 and 1, 2 form. Low or high, simple, in the form of energy, in the form of voltage, right? But for communication, for explanation, for talking, we say, hey, 0 and 1. So 0 and 1, you can say the bit, just like we understand the bit of information, instead of saying, hey, high voltage or low voltage, right? High voltage or low voltage, instead of saying these two, we are saying the bit. So similarly, if you group 8 bit, then you can say byte. Similarly, you can combine 1024 bit, you can say this is the your kb, then mb, then gb. So see a different representational, you can say. So let's do some basic example. So for example, you want to convert your 500 kb to MB. Simple. So if you aware this sequence, you have a bit, byte, a kb, MB, GB, TB, PB, YB, GB. So pretty clear. If you want to convert here kb, I want to convert kb to MB. Here our kb, I want to this convert to MB. Here I want to go. Means ki I have a KB data, but I want to speak data in the form of MB. So whenever you can say this is the smallest unit and this is the largest unit, biggest unit. So whenever you are going to convert from one small unit, this small unit to the big unit, then what you can do? You have to use the division operation. Just divide them 1024 and you can get the data. So whenever you are going to convert, hey, this is the my 1 kb and I want to convert an MB. The MB should be the bigger capacity. Okay, that means they can easily go inside. That means the outcome would be always less, means something remain available. So here whenever you can easily convert here, that means you can get some fraction number. Okay, due to that, say we have to go to the divide. So you can also visualize here, understand each, this is a very small unit and this is the 8, this is the big unit. You can say kb is the more big unit, mb is the more big unit, okay, gb is the more big unit. In this way you can visualize. Similarly, tb is the more big unit in this. So whenever you are going to convert your smallest unit to bigger unit, you have to go divide them. So it's another example. You're going to convert 2 GB to MB. Here I am going to convert GB to MB. Here our GB, here our GB. I am going to convert to the MB. That means here I am going to from higher to lower. Then you have to just apply the multiplication. So conversion from lower to higher also possible and from higher to lower also possible. So whenever you are a small unit and you're going to convert to the bigger unit, you have to do the division of 1024. If you have a bigger unit, you want to convert to the lower unit, you have to apply the multiplication. This basic simple rule. And all the conversions between MB to KB, KB to GB, GB to TB, everything. We have two operation only use. We have to use multiply, we have to use division. So whatever the conversion happen, be careful look what the customer want. Kind of read. Hey, let's see example. Here I want to convert TB to GB. So here TB is this information. Here this information we have. This information we have. I want to convert to the GB. That means I want to go higher unit to the lower unit. That means we have to do multiplication. We are just going to the multiply. So here, whatever the 3 multiply 102, this is the 307 your GB. So notice here I am talking say 3 TB and the same A word you can also speak 3072 GB. Both are the same. You can say hey 3 terabyte, terabyte you can say, or you can say another language. You can say 3072 GB. So this is a different tongue to speak. Both are the same thing. You can say 3 terabyte data we required, or you can say 3072 GB required. So our objective is as simple. The 3 terabyte is more simple. So whenever you have a larger number, a bit byte unit, you have to go bigger units, bigger unit. So these conversion is not impact your actual storage. Just these are the simple to talk, simple to convey our thoughts. If we memorize this sequence, generally we everyone I think know this. I'm not saying bit, byte, kb, mb, gb, tb, pb. If you are aware this, then you can easily understand any kind of conversion customer want from here to you want to they want to kb, you want to speak not in a kb, I want to speak in a pb. That means you are going to convert your smaller unit to the bigger unit. That means you have to divide. You have to divide first here, then divide again, then divide them. You can say sequentially you have to divide. You cannot just divide directly kb to gb here. No, because they are sequentially. So please be careful whenever you are converging some different unit. Let's you want to convert byte. We have let's have byte data, and now you want to convert to the gb. So this want to speak in a gb here. So if for GB, you cannot just go dismiss. You are going to surely talk about the division because you are going to smaller unit to the bigger unit. We are going to divide, but what the number you are going to divide? 1024? No, we are not going to divide to 1024. You can say, hey, convert GB. We divide 1024. Multiply 1024. GB to MB, GB to MB. But whenever be carefully, first you convert byte to kilobyte. Just divide 1024. Again, now you have a kb, then again divide 1024, you can get the mb. Again you divide 1024, then you get the gb. So in this sequence you can get the simple mathematics, right? So go by sequentially. You have a byte, can divide 1024, get a bit. Kb, then divide 1024, get mb, then divide 100, then get a gb. So any permutation combination you can get. Okay, let someone we have a hey we have a data in the JB. I want to convert in a bit. Okay, how much bit data would be? Just want to convert to the bit. So here you are going to convert your big unit to the small unit. So you have to go multiplication. So what number you are going to do multiply? Only 1024. Whenever you multiply 1024, it's become a MB. Then again multiply by 1024, then become a this. Again multiply by 8, then become this byte. Again multiply by 8. In this way you get the bit. So sequence wise you can get the multiplication. Be careful. Any example, any kind of permutation combination you can do. Let's say I have a petabyte data. I want to convert to the KB. You cannot just you can multiply with first 1024 get TB, then multiply by 1024 get the GB, then multiply by again get the MB, then multiply again get the KB. This is a sequence we have to, if you are aware, you can just understand 1024 is the multiplication. Okay, so hope might be it's clear. This if you just remember this sequence, then you can easily apply any kind of conversion. One rule, if we have a option 2, you are going to the do multiply, or you can go to the do division for conversion. Division only happen whenever you are going to convert your a smaller unit to the bigger unit. Means you are going to is whenever you are going to conversion from top to small to down, then we have to go this division operation. Then you go to the division operation. Whenever you're going to down to up, down to up, then always you have to do multiply, so that you can get the, this is the basic mathematics. Just already you know, but just rephrase. This is the way we are going to calculate. And sometime whenever we talk about the application performance, throughput, latency, we just we should aware this the basic units of your times. Like generally nowadays we are talking our performance of system in the millisecond. Generally, calculation happen in a millisecond. So you can say 1,000 millisecond consider as a 1 second. Someone say, hey, I want to not the second, I want to minute. Again, that means your 60 second become a 1 minute, 60 minute become a 1 second, 24 hour become a 1 day, 7 day become a 1 week, approximately 30 day become a 1 month, and 12 month become a week. So might be someone want to calculate the storage for 1 year or 2 year or 5 months or 10 years. So these calculation. Similarly, maybe here 1 year approximately 365 days. If let's give calculate per day the size, then what would be the year? Just multiply by 365 day, you can get the yearly. 5 year multiply with more five. So these are basic units, and these are also help us to talks. And these are the basics formula. Generally in the system performance, we are whenever system design, these two terminology already we have discussed, throughput and latency. So while the doing the calculation, so these are the only formula. Whatever the number of requests, if you divide by time, then you get the throughput. If in the particular time frame, what the number of requests you process, it's the latency. So formula is the same, just that throughput means the number of requests served by per second. Or similarly, in the latency, always talk the particular second, the number of requests, maybe how much times. So time divided by number of requests, get the latency. If you say number of requests divided by the time, then you will get the throughput. So these are two basic matrix. Always we have to ready to talk, calculate for your system. What is the latency? What is the throughput? So these are the some basic units in the case of latency. If you maybe generally latency talk about the seconds, maybe like very maybe I want to slow or high latency. Then say, hey, high latency system or low latency system. That means our latency is the delay at time. How much time? So always want our latency should be as low as possible. So low means if the second before millisecond, the millisecond, that's more good. If you talk the microsecond, more low, nanosecond, more low, picosecond, more low. So latency is going to reduce. That means maybe in the second you want to optimize your performance system, it become a response time in a millisecond. If you are optimizing, you are reducing your more latency. That might be talk your performance in the term of microsecond, might be in terms of nanosecond, might be in terms of more low latency means your system is very high performance. So these terminology second, millisecond, microsecond, nanoseconds or picoseconds are used. This is means one divided by thousands or one divided by again millions, one divided by again billions, one divided by again this is the number. So generally latency with this conversion happen, system is very high performance. Why to do? They are going to talk more low units. So second is generally in our real life, always we talk second. How much second you solve this problem? Yeah, how many minute? So generally in the computer system, very system is very high performance. So we are going to talk more low latency, means maybe millisecond. Nowadays, generally all the microservice or the applications or the social media talking, calculating his performance in generally millisecond. These are the preferable, you can say choice. But if our system is more performant, then we talk about the even a microsecond, even a nanosecond nowadays. So lots of these terms you should aware. Let's similarly talk about the throughput. Throughput generally have a very different perspective. Hey, you can say requests per second. Let's see the number of requests served by person, maybe 500 requests served by per second, or maybe 5,000 requests served by per minute. So here, whatever the number of requests served by maybe per talk minute or second or hour or day or year. So these are the throughput. The throughput here, number of request here can be maybe transaction per second or task per second or process per second or message. This hey, how many messages per second our system can consume? Let's see our IoT devices sending lots of messages to my system. So I'm just going to the measure in 1 second how many messages our system can process. Maybe 50 messages, 100 messages, million messages. So million messages per second is the my throughput. Yeah, 50 messages per second. Similarly, then maybe data size, the data per second, how much data maybe you can process in a 1 second. Let's say you are your application receiving the data in the terms of bit or in the terms of byte. So how much bit or byte or GB your system is going to the process are going to complete the storage. So similarly, you can say throughput also can measure in a different format. The throughput have a different terminology to talk. Maybe the bit per second. So let's you are downloading the some video or file on your machine. So what happens? Those the bits are going to download on your local machine. So here you can start. What is throughput? What is the rate of the transferring data? Generally, say hey BPS bit per second, or maybe KBPS kilobyte kilobit per second or megabit per second or gigabit per second or terabit per second. So these are the different terminology. Sometimes we talk in the terms of bit. Similarly, sometime we talk about the byte. Generally, hey, byte per second. Maybe here say, hey, kilobyte instead of bit. Here say kilobyte per second. Here say megabyte per second, gigabyte per second, terabyte per second. So these are the standard units to measure your throughputs. So here someone say ki megabyte. You can understand what do you mean by megabyte. Or yeah, KB per second. KB means kilobytes per second. Okay, and that means 1024 byte per second. If you can multiply by 8, you can get the bit. So you can again our higher we can say unit you are going to the lower side always go to the multiply, and if from the higher to go to the lower you can get division, and in this way you can set the different throughput. So whenever you are going to store maybe talk about the block storage file storage, so we are talking throughput in the terms of if your rate is very high, maybe we could talk about the byte kilobyte per second megabyte per second or terabyte per second. So these are all of the different you can say communications terms which help us to easily we can communicate our thought to the other human, but the system perspective system can handle all the data in the only terms of the bit. So let's again take some simple example which help you to understand this um, while the system designing why these calculation are simple maths required, because this simple calculation give you the broader view for your system, and once you know the high level capacity of system while designing it's help you accordingly you have to select tool technology framework components. So here, let's a simple example. There is one social media platform. As just hypothetical assumes, they are handle 1 million requests per second. So we have a one social media platform. Whatever social media platform you use, uh, from one user perspective, it's okay. Hey, I'm going to use the my Facebook or Instagram. Okay, but from my perspective, it is a one. I'm a one user. But the system point of view, system is available 24 multiplied by 7 across the geo location The millions of users are try to access this application. So question is that 1 second, how many requests my system serve? So this example say let's get 1 million requests are served by my system. So let's example, whenever one request come. So this request also have some size, how much data they are sending to us. So let's assume every request are required to 2 KB of data to the process. That means one request come and our system going to the process 2 KB data. Here question, we want to calculate the total data process per day. So our system, we are going to calculate in 1 day how much data they are going to process, so that we require the storage size similar. And similarly, let's my system going to continue work in a 1 year. Then what storage, what size we require? Question is clear. Now we have social media platform. Our platform have a capacity 1 million requests they can serve. That's good. But each request required 2 KB data to the store in the system. One request 2 KB, another request, because our systems are doing lots of whatever request come, lots of information going to track. They are approximately required the 2 KB data to store. So first we have to calculate 1 day per day how much data we are going to the process, and similarly 1 year. So in this way, you have to understand your system. So let's understand step by steps. So first step, what you do. So first we calculate, we know our system is maintain 1 million per request. So this is the 1 million. 1 million is 3 or 3 6. Whenever you say 1, 10K power 6 or 1 and 6 0, it's become a million. So here say ki 1 million requests per second, and each request take a 2 KB data, right? That means we are multiplying this 1 million to 2 KB. So overall you can say 2 million KB per second our system store. Means ki every second our system are going to store 2 million KB, yeah, storage required. So now we can calculate per second, but we require the per day. So how to calculate day? We already know. So we have a second. Then if multiply by 60, I can get the minute. I can multiply by again 60, you can get the hour. And then you can multiply by 24, you can get a day. So these are basic methods, all you know. So whatever the year 2000, 2 million KB data per second, I am multiply 16, it's become a per minute. I can multiply by 60, it become a per hour, and after that we apply 24 hour, that become a per day. So even overall, 1 to 7 8 kind of a KB per day required. So notice here, this is a very big number, very big number. I'm not able to read properly in the KB form. So due to that, we have a technique. Can I read this number simple way, which easily I can talk, easily I can memorize? So notice here, this is the 800 million. Now 172 billion 800 million KB per day storage required. Now our system, let's going to the surf coming the year. This is a 1 day. Now let's calculate the 1 year. That means multiply by 365, because 1 year 365 days. Just multiply the 365 days. So you notice I am getting this big number KB per year. That means here once this is thousand, this is the million, this is the billion, this is the trillion. 63 trillion 72 billion KB data required. So notice this number, even talked about the KB. Notice you can convert to the bit or byte, how big this number. So this is the challenges for us to talk this big number. So why not we can talk some memorizable, very simple number. Due to this, the lots of units are developed and lots of conversion you need to require. So let's simple calculate in the memorizable terms in the thousand, so that we can easily speak them. How to speak this large number in a KB? So whenever your any bit going to more, so yeah, conversion always required. If you have it only 3 bit, 4 bit data, you can talk about the bit. But this go more than 8 bit, then it's talk about the byte. Similarly, it's go more than 1024 byte, talk about the kilobyte. Similarly, it's go more than 2 to the power 20, to the power 30, to the 4. So we have to need the new measurement unit to talk. So here, this is a very big 63 trillion 72 billion KB is a very tough to task and explain, and other person also not able to easily grasp this number. Okay, so let's convert these in the again some specific units. Okay, so here our objective, we are going to convert, we have a big kb number, big kb number. Now I want to go convert to the some smaller number, because this is a very big number, very big number. I want to reduce them. What you can do, we have to divide them. For reducing any big number to the small, we have to divide. Let's divide 1024. So whenever you divide 1024, you can go to the next, it become a kilo to kb to mb. Now it is your mb, but you can convert your kb to mb. Now still this is a very big number, might we cannot speak. So let's again divide 1024. Now you get the this number. That means at least million, 60 million GB. But this is it's a bigger number. Can you again reduce them? Again divide them 1024 by, then you can say 58,000 TB. So you can say 1 year you require the 58,000 terabyte. So this different measurement units help us to make simple communication between the team, between the architecture, between the other members. So whenever you are going to talk the bigger number of bits, you always divide 1024, 1024, 1024, 1024. In this way, again, maybe if you are bigger, again you divide to 1024 and you get the TVs to TV. So my is clear. Whenever you are going to convert, let's say you want to convert to KB to here a TB, so you cannot directly divide 1024. First convert KB to MB, KB to MB, dividing by 1024. Again convert MB to GB, dividing by 1024. Again converting GB to TB, divide by 10. So you have to go sequence by sequence so that you can easily do it. Okay, so hope this information help us why these convert calculation help, the different units conversion help. Okay, so let's another example. Similarly, let's we have one system. Okay, they need to store 100 million user profile. Sometimes whenever you are going to system designs, and you have to also maintain user profile or customer data. So what data size would be? So let's see here. Our customer say, let's we are going to manage 100 million user profile. So whatever one user profile, what the each user profile size would be. So if let's for simplicity, let's user profile size is the 1 KB. Can be 2 KB, can be 5 KB, can be 10 KB. Let's say maybe 2 KB or 3 KB or 5 KB. So you have to calculate for 100 million user how much storage I require. So whenever we have a number of maybe number of requests or number of user, number of profile, the first you know the number of profile, maybe million, billions profile, and after that you just find out the size of one profile. The size of one profile here, just assume the 1K. Then we can simple do mathematics and calculate. Here say 100, 100 million minus that means 60, 10 to the power 6, 10 power 6. So this is the 60 means 100 profile. Each profile size of 1 KB. Just multiply by 1. So this is the complete 100 million KB. So 100 million KB. I want to speak some minimum number. So you can just divide. You can convert to KB. You can get KB. No, it's so big number. Can you convert? It's MB. Can you more convert? GB. So GB is the 100 GB. Is the top easily. Easily you understand. That means your system required 100 GB data to storage. So you can plan your data storage capacity at least required 100 GB data. So talking 100 GB is very easy. Instead of talking 100 million KB. So this is the just simplicity, the communication between the our team. We are need to convert KB to MB to GB to PB. So whenever you are going to convert, you have to just multiply, divide them, divide them. So it's a simple basic mathematics. Don't confuse. Whenever we have a very bigger number and you want to simplify less number, that means we have to division. And you have only the less number, you want to make a bigger number, you have to do multiplication. So the simple rules here. Let's sometime someone say, hey, let's calculate byte per second. So let's see there. One system handle 100 MB data per second. So here customer talking, our system are able to handle 100 MB data per second. But I want to calculate in the byte. Someone say, hey, can you calculate in the byte wise? Or someone say calculate in the bit wise. So similarly, now here we have MB, we have MB. You want to convert to the byte. Notice the first byte, after that the kilo, after that your MB. Now here MB, you have to convert, go to the first KB, then convert to the byte. So here say, hey, whatever the 100 MB, I am going to multiply by the 1024 and get the KB. Then again, I am going to multiply by 1024 and get the byte. So you can say here 100 million byte per second. So whenever you are going to the bigger unit to the smaller unit, you have to multiplication. Whenever you get a smaller unit to the bigger unit, you have to do division. So these are some basics maths. This really help to understand your overall system capacity, the storage, power, speed, right? Let's simple another example. So maybe your system. We have a they want to store. Let's we want to store 10 million user profile. 10 million. Each user profile can let's say 2 KB size. So what? How much storage you need? So you already know we have a 10 million profile. Each profile have a 2 KB. I just multiply. That means we have a 20 million KB storage required. But talking the so larger number, can you reduce the number? Let's divide and then get the 20 MB. Let's again divide it so number. Let's say 20 GB. The 20 GB is a very sufficient. Hey, for storing 10 million user profile, we require the 20 GB data. So these simple math calculations help us to communication between your architect, your team, your system, your top management. Because this you have to talk your high management because the storage required your financial number. You have to pay something. So if this number you talk, hey, management, millions and millions of bit data I want to store. Someone cannot understand. Someone cannot visualize. So good option for the top management, from the customer, from client. We always use the big higher unit to talk. So that simple number 1, 2, 10, 100 within 100, yeah, within 1,000 manageable. Anyone can memorize. Yeah, 2,000 GB, yeah, 50 TB, yeah, 5 MB. Right? These are the make a simple communication. So simple understand this communication. Why this conversion required to make a simple communication so that easily anyone can understand the meaning. So here notice for again in the system designs for more simplicity. We while the conversion, always notice we have to divide the 1 0 2 4. Why? Because it is a 2 to power 10 byte data. So generally, why do we have divided 1024 1004? Because we are talking about the binary system. A binary system generally always took a power 10, your it took a power it took a power 20, took a power 30, took a power 40, because it is the binary system. So in the maybe in the short period of times, this is a calculation. Let's see, 1024 multiplied by 1024 multiplied by 1024. It takes some times, and it's not, so make some uncomfortable while communication. Might be, let's multiply by 1024 multiply by 1024 multiply by. Someone asks 1024. It's very hard to be do quickly. We can do, but it's take some time. So for the simple calculation, instead of multiplying many times 1024 multiply by 1024 multiply by 1024. This is the one. And many places we have to divide. Whatever the big number, we have to divide 1024. 1024 division, again divide 1024. Okay, this division and multiplication with the number 1024 is hard, take time, you can say. So for doing the simple mathematics, we have some different approach. Instead of the binary system, why not we can use a simple decimal system. Decimal system means, that means the in the mathematicals which we learn our school and college. In the decimal system, instead of power of 2, it is the power of 10. You can say power of 10, power of 10, 1 2 3 4 5. Easily mathematical happen, easily multiplication happen, easily division happen. If you can say 10 to power 2, 10 to power 3, 10 to power 4. If divide 0 0 here, it's simple, just cut them and minus, reduce the point. Very simple. So if you want to divide with 1 0 0 0 0 number, easily division happen. Multiplication, if this is the 0, if this is the 0 0 0, you can say divide someone, divide some. I can easily say, hey, 10 k power here maybe 3 3 3 9. This is a simple calculation. So for doing the simple mathematics, we are generally, while communications, we are not going to use the binary system. Instead of you are talking about the simple mathematical system, decimal system, which generally we learn mathematics since our childhood. Binary system is more and more fit for the computer system, but actual storage calculation always happen in the binary system. But for simplicity, for simplify your communications, we prefer to calculate the decimal system. Power up, instead of power up 2 ka power, instead of power up, instead power up 2 power 10, I can say 10 power up 3 or 10 power up 6, 10 power up 9 in this sum percent. So this R calculation is very hard. Someone say, hey, what is the 2 to the power of 10? At 2 to the power of 20, what happened? It's very hard to calculate. Someone say, what are the 10 to the power of 30? Just you write 1 and 3 0. This is simple calculation done, right? 10 to the power 6, I know 1 6 0 done, right? This is the way. So this make the simplicity. So generally, please, for simplify the calculation, use the decimal system. So in decimal system, instead of 1024, in decimal system, instead of 1024, we just say 100, thousand. Just now our all the multiplication or division happen with the thousands. That's so simple. Divide by thousand, so simple. Divide by multiply by thousand, so system. So for the while the maybe interview or any times you want to calculate this easy conversion, let's just learn division or multiplication by 1000. 1000 matches is 30 just. So if that means kilobyte, 10 to power 3. Simple. Megabyte, 10 to power 6. 9. This is the table of, you can say table of 3. Generally, all the general calculation we are doing the table of 3. 3, 3 1 is 3, 3 is 3, 3 3 9, 3 is 4, 3 5 is 50, 3 6 is 80, 3 6 is 21, 3 7 is in this way. So always use the table of 3. Okay, and so in this way, simply you can do your basic mathematics. Okay, division also happen very easy, multiplication also very happen, and you can easily make conversion. Just divide by 1000, again divide 1000, again divide by 1000. So any big number, that's any big number you want to divide by 1000, multiply by 1000, let's say 6, 3 4 6, just point them and division happen. So divisions of 10, 100, thousands are very, very simple. So decimal system help us to do calculation is very, very simple. So while communication, while the conversion, let's please take this concept of the decimal system to calculation. Just divide with the thousands or multiply with the thousands to make any conversion. Okay. And similarly, just for number systems, we should aware what do you mean by, you can say 10 about 3. That means you can say here kilo, or you can say this thousands. 10 to power 6 mega, or you can say million. 10 to power 9 you can say billion, or you can say GB. Or 10 to power 12 trillion, you can say terabyte. Quadrillion, quintillion, these are the just table of 3. 3 1 is 3, 3 2 is 6, 3 3 is 9, 3 4 is 12, 3 5 is 60, 3 6 is 80, 3 7 is 21, 3 8 is 24. Generally, your mathematical number system also follow the combination of 3. Notice, just multiple of 3, you can say 1000, multiple of 3 billion, multiple of 3 billion, the million, billion, trillion happen. Just increase the power of 3, power of 3, power of 3, multiply by 3. So in this way you can memorize this table of 3. 10k power 3, that means 1000. 10k power 3 or 6 million, billion, trillion. Similarly here you can visualize here the kilo, then 10 to power 6 mega, then 9 giga, terabyte. So this mapping between your simple mathematical number system, you can with your KB, MB, GB, TB, PB. So your conversion is very simple. Kilobyte, megabyte, gigabyte, terabyte, just 10k power. You can say understand your, at least you aware your mathematical number system. 1000, then million, then billion, then trillion. This is happen just 10k power 3, 4, 6, 9, 12, 15, 18. So this make just comfortable to us. At least we know mathematical units, and from the mathematical units we can easily convert. Hey, 3 means kilo, 6 means MB, 9 means GB, 10 means TB, 15 means TB. So this is the simple memorizations you can say. A conversion also happen very simple because you have to just multiply by the thousand or divide by thousands. And sometimes, whenever you talk about the latency, the lower number is this is the bigger number. Sometimes you want to talk the units like second. So these are the terminology we have to cover, like millisecond, microsecond, nanosecond, picosecond, femtosecond, altosecond, zeptosecond. Similarly, also this is also power of the 3. This is a table of 3, but 1 divide by. Whenever you go to the fraction means 1 divide by 1 divide by your 10k power 3. So this is also here. If you're going to the fraction at time or second, at that time also the table of 3 happen. 3 1 is 3, 3 2 is 6, 3 3 9. A table of 3 happen here, and here just you can write 1 by 10k power 3, or you can write 10 minus 10 power minus 3, or 0.001, or here 6 means after dot 6 number 00001. Similarly, 10 to the power 9. You can say 1 divide by 10 to the power 3 are the millisecond. Okay, so these are the terminology are very basic mathematical calculation happen. You can simply say, hey, micro, you want to understand milli means thousand, micro million, nano billion, picotrillion, because this is the, one by the same. Here the thousand, million, billion, trillion happen. So if you say ki your all the calculation happen very simple with a basic your mathematical unit, thousand 10 to the power 3, then million 10 to the power 6, then billion 10 to the power 9, then trillion 10 to the power 12. If this happen, one divided by that means the milli, macro, nano, pico. This is not flat. That means again kilobyte, megabyte, gigabyte, petabyte. In this way happen. So you can just review this, and you can easily mind map. These are the numbers with your mathematical, because we are more comfortable with your mathematical unit. So these are the number, whatever the millisecond, microsecond, nanosecond, yeah, kilobyte, megabyte, gigabyte, all you can map with the basic your mathematical number with a thousand, million, billion, trillion. These all just happen 10 power 3 table of 3 just. So hope this information is give you little bit comfortable. These calculations and the storage, latency, throughput is very simple. Just you understand, be carefully, and know these basic rules. You understand the hierarchy, the which is the smallest unit, bit, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, in this way. Similarly, if you know your mathematical number, thousands. Similarly, you already know thousand, million, billion, trillion. You can make the mapping, and easily you can convert any to any. If you want to convert uh, top to bottom, bottom to down. If you go to the small unit, the big unit, the big unit, the big unit, you want to be bigger number, you can do division. You have a bigger number, you want to reduce number, reduce the unit, means you want to go to bigger unit, you can just say divide them, divide. A dividing with a thousand, a dividing with a multiply with a thousand is very simple. So whatever we did calculation with the 1024, let's you can try with a 1000. Very simple. Because due to that, initially I did all the calculation with a 1024, and let's you can do try all this calculation, million requests per second, storage, throughput, latency, bit per second. Just want to calculate and apply this mathematics. This is only feasible how much you do practice. This is the only, the math is the simple rule. If you want to know the mathematics, you need a practice. Without practice, math cannot be familiar. So I'm just, this is my simple suggestion. In the system design, you must do the basic mathematics about the your storage, your throughput, your latency. The storage is very required, because finally you are going to design system. You must know how much. Let's customer say I am going to here 5 million users. So you must note key how much storage we require for the 5 millions, right now. So this need a simple math, and this is math only happen with the practice. So let's do the basic calculation of this, and you feel more comfortable with the calculation part of the system designs. Storage calculation basically, because storage is the key terminology point section of your system designs. Because how much data you are going to store in systems, you must know, so that we can plan those database, file system, block storage, whatever you want. So hope this information is something help you. So just this is for the day, and I'm just trying to say thank you.